Well, good evening all. So, as you can see here, I've got one of my early variants here, and I was trying to track down a problem. So, if you note the frequency here, you will see that we were on 27.75 megahertz even. Well, this is running similar software to what would be running on this, except of course this is a much earlier variation than what would be on this. Of course, we got different displays and so on and so forth. Just overall, it's different stuff, even different microcontroller. The microcontroller on this is much faster, much more GPIOs, things like that. It's just, it's just different, but the synthesizer is essentially the same. So the problem here is on frequencies such as this, and this is what I've got in the 148s, and this problem has not cropped up. But if you look at the radio here, we've got a signal. It's just a carrier. And if I change, listening to the hiss, if I just change the frequency a little bit and see where, it changes, we're changing frequencies. That's just that is the frequency of the noise, of the carrier. And this escaped me because I never went to 27.75 even. When I was using like this variant, and I had this channelized, and what I mean by channelized is it's just I don't have two encoders attached to this, so I've got to sort of move this one encoder between the two positions, because one was meant to be the clarifier, the other one was meant to be the channel selector. So channelize is what I mean is by this. So I would just flip through the channels, and like that would be 27.755, and there's no tone, and you'd go by it and there would be no evidence of a tone, so you just would miss it, which I did. But when I go to, blasted thing, I should have put two encoders on this. But if I go back here, okay, we got nothing until I start, going down. You can start to just about hear it. So when I was using this one, which is predominantly in VFO mode, and I would just sort of spin the knob, there you are. You would end up on 27.75, and I'd go by it and see the needle, jump and then go away as you're spinning around, and you're like, okay, well, what's that? And you go back to it, and sure enough, you have on this frequency, you have a carrier. And that's the same thing with several other frequencies. Now, with 25 megahertz, we kind of expected that. So if we go to 25 megahertz, well, yeah, we expected that, because crystal oscillator, our temperature compensated crystal oscillator is running at 25 megahertz, and of course we're slammed out. So there's leakage, and that's to be expected. So there's a couple of other places. I can't recall where. I think this is one of them. Yeah. It's just there's a few places where there's a tone, and that may or may not bother some people, but it bothers me a lot. There's one somewhere around here. There's just in a few places. There's just a tone, and like there, you know. But I don't know. Anyway, long story short, I tried to. I've been mucking around with filters and things like that. The only issue that I'm having is the fact that I don't have a tracking generator. And when you're mucking around with filters, yeah, the math is only going to take you so far. And that filter actually works, but it doesn't get me the roll-off that I want. And the only way I think of really doing that is, if I had a tracking generator. So I'm kind of stuck until I can get my hands on a spectrum analyzer with a tracking gen, and make or design an adequate filter for this, which seems to be rather unfortunate that I just didn't catch this before, because when you look at the output of this on a spectrum analyzer, you don't see that tone until you're actually on the frequency where it's being generated. So, because you got to remember, this is 35 megahertz out, but it's generating, tones, below that, and it's a very low, it's very low. It's like negative 80 dB. It's below the 35 megahertz. I mean, it's really low. But here's the problem: you're injecting it right into the radio, and that's going right into the receiver, and yeah, it's an issue. So I need to sharply attenuate everything below 30 megahertz coming out of here, and hope that works. And that's kind of the issue with this one. So if anybody has any suggestions, I'm all ears. But until I figure that particular aspect out, and here's the thing: I actually tried with an SI 570. I have some SI 570. They're similar to the 5351s. It's just a ceramic package. It looks like that crystal, much bigger though. And they actually have a similar but not the same issue. The tones are just in different places. So anywho, suggestions, comments, critiques. Until then, I'm probably going to put this particular guy up and revisit it at a later time when I actually can think of a solution to this problem. Because when I tried the the various DDSs, they actually have similar problems. I just need some filters, and I'm thinking an active filter with op amps will probably do the trick. To roll off the anything below 30 megahertz and just to attenuate the hell out of it so that it's not there. So I don't need any more signal out of this thing. This thing is phenomenally strong. And I tried reducing the output power on it, and it does help, but and it helps in conjunction with a filter, but it doesn't eliminate it. So I don't know. I might just I think I might just put this one away for a little while, and so you can think about a solution, and probably pick up the 980 pretty hard, and see what I can come up with on the 980. I got most of the stuff, in fact, to prototype a front panel for the 980, so I might just do that instead. So anyways, till next time, guys.